So this is a demonstration of how we can use DFM Concurrent Costing and the new features that we've included to analyze a piece of sheet metal. I'm going to import a CAD model. You'll notice there's a new button on the toolbar to allow me to do that more quickly. I'm going to pick this part here, and the software opens up the model and shows it to me like it's done previously. The envelope dimensions have been extracted from the model, and now I can select a process and material to get an initial manufacturing cost estimate. So I'm going to pick laser cutting and I'm going to pick aluminum. And so here we get an estimate of the cost of manufacture based on the default choices that the software has made about cost of materials and batch sizes, and also some initial guesses that have been completed based on information from the model and some best practice things from the software. But as we know from our previous work, we need to refine these estimates and get a better answer. And so the way that was traditionally done was by typing in these values here. Now you'll notice that there are more of, and in some cases, calculators in places where they weren't before. And so rather than being a black box where you just import a model and you get a cost and you really have no idea what had been assumed in terms of what the manufacturing steps were going to be and what features were going to be manufactured, we chose to implement this new feature by putting the CAD information into the geometry calculators. And so what happens here is I need the unfolded length and width of this part, for example. So when I click on the unfolded length here, I have the option to use the traditional things that I had used before to add line segments together if I was measuring them off a model in my CAD system, or if I had a drawing and I was adding them together, or if I had a competitor's part and I didn't have a model and I was physically measuring them, I could use these to help me calculate that number. You'll notice the addition of these two new buttons. I can use these to now measure features off the model. And so in this case, I'm going to select just this one line. That's the unfolded length of that part. If I say OK, the software measures that and puts it in there for me. The unfolded width, now I can bring up a calculator for that. I can again tell it I want to measure it off the model. And when I make my selections here, it's going to be that edge and that edge and that edge that define the unfolded width of this part. So when I say OK, now the software puts that in there for me. Again, the external cut perimeter, I'm going to measure that from the model. I can, again, pick my edges here. In this case, it's this one, this one, this one, this one. And I'll select my way around the part that defines the external cut perimeter. The number of holes, I can click on this and again measure these from the model. And so you'll notice here two things. One is when I make these selections to define a hole, the software calculates the perimeter of that hole, one of the inputs we need, but it also counts it. And so as I make these additional selections here of these 4 large holes, you'll see when I'm finished, I've got a count of 4 holes and a perimeter for them. I'm going to add the remaining holes here so you can see that it does in fact continue to count and add up all of the perimeters of these holes for me. And so now I've got 8 holes and roughly 10 inches of perimeter. When I say OK, that gets transferred in. And then finally I need the length of the bend line. There's just one bend in this part, but if I had multiple, I could do these selections in multiple areas. And when I click calculate, I now have a pretty accurate, as good as I'm going to get accurate, estimate of the cost of manufacturing that part, with information coming from and being extracted from the model, but with that user interaction that we wanted in order for you to know what it is that you'd selected and what you've told it is in fact going to be manufactured. So these calculators have been placed throughout DFM Concurrent Costing in all of our models and in all of the places where it made sense to allow the user to measure things from the model and get estimates of the data. So for example, the maximum section thickness of an injection molded part is now something you can measure off the model. The projected area of an injection molded part, the perimeter of a die casting, those are all things that we can make use of the CAD model and those calculators for. By implementing this feature the way we did, it also afforded us the opportunity to put these calculators into our operations library. And so we've done that. We've gone through the library and where it made sense, for example, for secondary machining operations. If you're drilling a hole, you can now measure the diameter of the hole and the depth of the hole from the model. So wherever it made sense, we've added those calculators. it's also then available to the user as an option to put those calculators into operations that they've created themselves. And so if I add an operation here, let's say to paint this part, we've also added a search function to all of our libraries. So if I type in here paint and click search, you'll see the software brings me to the painting category, and I can pick this wet smooth paint as the thing I'm going to do to this part. And when I click calculate, I get a cost like I did before based on these default numbers coming from the operations library. But what you see here is painted surface area has a calculator, and if I click it, it's smart enough now to know that we want surface area here, not length, and so the calculators are different depending on the type of information that you're trying to calculate. And so when I make this selection here, this will allow me to now pick surfaces on this part that are going to be painted. So I'll pick, let's say, just the outside surface. So if I roll this around, you'll see the inside surface have not been selected. And if I say OK and click calculate, that's the cost of painting just the outside surface of that part. And again, like you would see before, that's the total cost of manufacture now, with information coming from the CAD model and giving us a quicker, more accurate estimate of the cost of that part. One final thing I'll add is, if we pretend it's a week or a month or sometime later that we come back to this, the software does remember all of your selections. And so if I come in here and I want to know, well, what were these 8 holes that I selected? When I bring the calculator back up, all of the selections that I made are still highlighted. And if for some reason you wanted to then make a change, you can do that. I can zoom in here and remove this hole and this hole, let's say, from my analysis. And now I only have 6 holes with some perimeter, and when I say OK, I can click calculate and see the difference in cost as a result of that change. So all of your selections are maintained, and they're all editable later on if it is something that you choose to do.